what is the order of acidity from weakest to strongest acid for these compounds? So we should take note of a few keys to determining the strength of an acid. So I'll jot those down really quick. Right, we want to determine. Number one way to go is stability of conjugate base. Right? The more stable the conjugate base, the stronger the acid. Think about it, the less likely it's going to be able to pick back up the proton that it lost. Right? The more stable it is, the more equilibrium is going to lie on the side of the conjugate base. So, keeping that in mind, using this we can show that also what counts for acidity is the size of an atom, the size of the atom that the proton's bonded to, the electronegativity of the atom that the proton is bonded to. Let's see, we also have electron delocalization. Let's just say delocal. Inductive electron withdrawal is another important one, and S character, meaning double bonds, triple bonds increase acidity, right? sp2 to sp, right? More S character, more acidic. Okay, so those things in mind. One more thing I want to point out is there's a table in your book that you should probably know pretty well for the approximate pKa's. Less than 0, approximately 5, approximately 10, approximately 15. Okay, so it's a messy 15, but that's 15 right there. So approximately 15 is water, alcohol. Approximately 10 is protonated amines. Okay? Approximately 5 is carboxylic acid. And less than 0 is protonated, R, should say R instead of is. Protonated, let's see, water, protonated alcohol, and protonated carboxylic acid, right? Okay. Okay, so that should be enough information for us to get this problem down. Let me grab a different marker here. Okay, so let's see. Well, this guy is carboxylic acid. Everything else is an alcohol, right? Another note. So for this pKa table, if you add a benzene ring to these acidic groups, you decrease the pKa by 5 generally, right? So if I replace this R with a benzene, then this would have approximately 0. Same if I replace this R with a benzene, it would be approximately 5. Right, so this is going to be even less. This is definitely going to be the strongest acid. So, because everything else is an alcohol, so everything else will be approximately 15 or 10 with the benzene ring. Okay, so this guy would be strongest. So from weakest to strongest is going to be number 4. Okay, so let's look at some of these other guys. Right, we have an alcohol without the benzene ring. This is a phenol, right? So that replace benzene with this R group, it drops the pKa by 5. Its pKa is going to be approximately 10. This guy, this is not attached to the benzene ring straight away, so it does not drop the pKa. This drops the pKa because of resonance, which stabilizes the conjugate base, right? So if we drop that proton and we put a minus charge here, we can delocalize the minus charge into the ring, right? So we can go like this, and let's just go there for a minute. So what would that do? We put a double bond here, and after that arrow, we'd have a minus charge here, right? And then we could do that again and put a minus charge now down here. So we can delocalize that minus charge all the way out through the ring and stabilize the conjugate base. That's why benzene makes these compounds more acidic. And this guy is sp3. So you can't, through resonance, do what I was just talking about with 3. So this will be the next strongest acid, right? Because these guys will be around 15, and this will be around 15. Okay, so this would be number 3. It's going to be our third here. So, comparing these two now, right? So, now this is where inductive electron withdrawal comes in for actually both of these guys. Right, so this is a carbon with 3 fluorines attached. Right? And this guy, instead of having a CF3, we have a benzene ring, right? And so both of these guys will withdraw electrons, which will stabilize the minus charge of the conjugate base. Right? Okay, so basically what it comes down to is which one's better at inductive electron withdrawal, right? And it will be this guy. CF3 is more electronegative than a benzene ring, right? Fluorine is as electronegative as can be, right? Well, yeah, F minus. Right. So, electronegativity increases in the periodic table on an angle towards top right. So fluorine's as electronegative as can be. It will do a better job of inductive electron withdrawal than number 4. Right? So this will be 2, this will be 1. So let's look for that order. 4, 1, 3, 2. Our answer is C.